Let's assume we have a fair coin, which is equally likely to come up heads or tails. In instances like this, where the two outcomes are equally likely, we can use probability theory to express the likelihood of a particular event by comparing it with the sample space. So one possible event is heads, another possible event is tails. And so if we want to model the probability of getting heads, well, we have one possible outcome where we get heads from all of the possible outcomes in our sample set, which we can call omega. So I've symbolized omega in purple here. So in this case, omega consists of heads or tails, or heads and tails. And we can use curly brackets to indicate all of the elements in the set and a comma to separate those elements. So we have heads or tails, these two possible outcomes. These are all of the outcomes in omega. So this is our denominator. And then in our numerator, it's the number of outcomes of the events. So if we want to model the probability of getting heads, if that's the event that we'd like to model, well, there's a 1 in 2 chance of getting heads because of all of the possible outcomes, heads or tails, heads happens one of those times. So one event over 2 possible outcomes. And it's the same for tails, where we have one possible event happening out of 2 possible total outcomes. As a second separate example, consider drawing a single card from a standard deck of 52 playing cards. In this case, the number of possible outcomes in the sample space, which we again symbolize as omega, is 52. So there's only one ace of spades in the deck. The probability of drawing it, therefore, is 1 in 52, because there's only one event out of the 52 possible events where the card that we draw is the ace of spades. So the probability of an ace of spades, and this is the standard probability notation, a capital letter P, and then in round brackets, the event. So the probability of having the event be an ace of spades is 1 in 52, and that comes out to about 2%, or 0.019. In contrast, there are 4 aces in a deck of cards. So the probability of drawing an ace, is equal to 4 over 52, because there's 4 possible events out of the 52 that are an ace. So in that case, the probability of drawing an ace is about 8%, or 0.077. As some additional examples to round this concept out, the probability of drawing a spade is 13 in 52, because 13 of the 52 cards are spade suited. And so the probability of drawing a spade is exactly 25%, or 0.25. And you can combine probabilities together. So the probability of drawing an ace or a spade is 16 in 52, because there are 16 cards amongst the 52 that are either an ace or a spade. So this probability is slightly higher than just drawing a spade. It's about 31%, or 0.307. And as just some further examples to illustrate the concept of probability thoroughly, the probability of drawing a card from amongst the 52 cards is 52 in 52. There is a 100% chance, or the probability is 1, that we will draw a card. On the other hand, there's no chance that we will draw a turnip. So there's only cards. So there's a 0 in 52 chance that we will draw a turnip, a 0% chance, or a probability of 0. All right, so that introduces events and sample spaces, the most fundamental topics in probability theory. Up next, we'll make things a little bit more complicated by talking about multiple observations as opposed to just single observations.